Welcome back to The Explainer. So today we are literally staring right into the eyes of a cosmic giant. We are leaving our solar system way behind to unmask one of the most visually stunning and honestly most terrifyingly named structures in the whole cosmos. I'm talking about NGC 2467, which you probably know better as the Skull and Crossbones Nebula. If you're into deep space, the birth of stars, or just some absolutely extreme celestial mechanics, you are going to absolutely love this explainer.
Now, right off the bat, I want to anchor us in the sheer, almost incomprehensible scale of our universe. Just look at this number, 10,000. This massive stellar nursery that we're exploring today, yeah, it definitely doesn't sit in our cosmic backyard. It is a staggering 10,000 light-years away from Earth. To put that into perspective, the light we're observing from this nebula right now, the actual data our astronomers are analyzing, left that region of space 10,000 years ago. That's long before the dawn of recorded human history. It's basically a cosmic time machine, and that immense distance is absolutely crucial to everything we're about to unpack.
But hey, before we go any further, we really need to make sure we're looking at the right skull. You see this a lot on amateur astronomy boards. People constantly confuse NGC 2467 with NGC 246. So our target, the one on the left, is a massive emission nebula in the Pup I constellation. You definitely don't want to mix it up with the one on the right, which is the Skull Planetary Nebula. That's a completely different, much smaller celestial object. We are focusing purely on the massive star-forming behemoth on the left today.
Okay, let's dive into this and quickly check our cosmic flight plan. We'll start by getting oriented with Welcome to Pup I. Then we'll move into Unmasking the Skull Nebula. After that, we'll look at the massive stars powering the whole thing in the Pup I OB association, before jumping into the hard science of photometry and distance, and finally, we'll wrap it all up with the chaotic internal motions and dynamics of the region.
All right, Section 1, welcome to Pup I. Let's figure out exactly where in the night sky we're pointing our instruments.
So our target lives right in the constellation of Pup I, which represents the stern of a mythical ship down in the southern sky. Scientifically, you might also see it cataloged as Sharpless 311. But what makes its location so absolutely vital is that it sits right in what astronomers call the window of the Perseus arm of our Milky Way galaxy. If you actually have a powerful enough telescope at home and you want to dial in the exact galactic coordinates, you can lock right onto it at 7 hours, 52 minutes right ascension and a declination of -26 degrees. It's literally perfectly positioned for us to peer deep into the galaxy's spiral structure. Now that we know exactly where it is, let's move right along to Section 2, Unmasking the Skull Nebula. So, NGC 2467 is an emission nebula, but let's break down that jargon for a second. An emission nebula isn't just some dead, floating cloud of dust. No, it's a fiercely glowing cloud of interstellar gas. But why exactly does it glow? Well, it acts kind of like a giant neon sign, ionized by the intense radiation pouring out of nearby, incredibly hot stars. And more importantly, this gas is the raw material for a stellar nursery. This is an active, bustling birthplace where brand new stars are actively forming right out of the cosmic dust. How cool is that?
And that brings us perfectly to Section 3, the Pup I IOB Association. Now, what's really interesting about this is that if the nebula is our glowing neon sign, well, we need to meet the power plant actually generating the electricity. When astronomers map out the specific family of stars living inside this nebula, they find a tightly bound grouping of massive, young, and incredibly hot stars. An OB association is essentially just a loose cluster of these giant stars. They don't just happen to live in the nebula. Their intense ultraviolet radiation actually shapes, carves, and illuminates the surrounding gas clouds. That is exactly what gives the Skull and Crossbones its terrifyingly beautiful face.
And sitting right at the absolute center of this stellar family is the reigning monarch itself, HD 64315. Now, this isn't just any star. It's an O6-type massive star. O-type stars are basically the most massive and hottest stars in the entire universe. They're incredibly rare, they burn unimaginably hot, and they live very short, violently active lives. HD 64315 acts as the central energetic engine of NGC 2467. Honestly, without the immense radiation pouring out of this specific powerhouse, the entire nebula would just fade to black.
So moving to Section 4, Photometry and Distance. You might be wondering, how do we actually know all of this? How do we figure out the distance, the temperature, and the composition of something so far away?
Well, to understand these distant stellar populations, scientists rely really heavily on a technique called UBVRI photoelectric photometry. Think of this as a highly specialized astronomical blueprint. By passing the light from these distant stars through 5 very specific filters, ultraviolet, blue, visual, red, and infrared, astronomers can precisely measure a star's brightness and its true color. It's basically a way of decoding the starlight to reveal the temperature, the age, and absolutely crucial for us, the exact distance of the stars in the cluster.
And this brilliantly illustrates what that looks like in practice. When this data comes back to Earth, it arrives as massive, raw observational tables. Scientists painstakingly record these measurements star by star, mapping out the visual and energetic footprint of the entire region. This isn't just about taking a pretty picture for a textbook. This is hard, quantitative data capture.
Then, once astronomers have that raw data, they plot it out photometrically. By analyzing exactly how the stars fall onto these graphs, they can calculate the reddening of the light caused by interstellar dust and mathematically prove the distance. It is precisely through rigorous, meticulous charting like this that we can confidently stand here today and say that this magnificent stellar nursery is indeed sitting exactly 10,000 light-years away from our telescopes. The math completely checks out.
All right, finally, we reach our last section, and arguably the most thrilling part of the whole explainer, Section 5, Internal Motions and Dynamics.
Let's move to this and see how it builds. Here we're looking at a kinematic study, which is really just a study of motion, within the HI2 region of the nebula. You know, when you look at a beautiful photograph of the Skull and Crossbones Nebula, it looks perfectly frozen in time, right? Like a painting. But this data proves the exact opposite. The internal gas is swirling, it's expanding, it's colliding. It is a highly active, totally chaotic environment pushed and pulled by the intense gravity and radiation of the stars inside it. By mapping the velocity alongside these internal kinematics, astronomers reveal the truly violent dynamics at play. We can actually see the differences in speed across the face of the nebula. The radiation from that massive O6 star HD 64315 is literally blowing the surrounding gas away, creating massive shock waves and these vast expanding bubbles. It's like a stellar windstorm on a galactic scale, churning up the very material that will eventually collapse to form the next generation of stars. It's a real game changer when you picture it like that.
So what should you take away from all this data? Well, ultimately, NGC 2467 is absolutely not a static object in the night sky. It is a living, breathing, incredibly active stellar nursery. Its entire structure is governed by complex, violent internal kinematics. And the whole majestic display is completely driven by the sheer, unadulterated power of rare O6-type massive stars like HD 64315. Which leaves us with the truly staggering thought to wrap up our explainer today. We know that massive stars like HD 64315 burn incredibly hot, which naturally means they burn through their fuel incredibly fast. Knowing the violent internal motions and the massive energy output shaping this region right now, what will this stellar nursery look like when these immense stars finally reach the explosive end of their life cycle in a supernova? Will that blast destroy the nursery entirely, or will those massive shock waves trigger an even bigger wave of star birth? The universe is constantly evolving, and NGC 2467 gives us a spectacular front-row seat to the beautiful chaos of creation. Thank you so much for joining me on this cosmic journey today. Keep looking up, and I will see you in the next explainer.